How exactly does short-term memory work? What are its limits? Can we remember an unlimited number of things at a time, or is there a set capacity? These are all great questions. Probably the most widely accepted model of short-term memory was created by Baddeley, the model of working memory. According to Baddeley, this term refers to a brain system that provides temporary storage and manipulation of the information necessary for such complex cognitive tasks as language comprehension, learning, and reasoning. This is a fancy way of saying that working memory both stores and handles lots of really important information. In Baddeley's model, there are four main components of working memory. The central executive is the command center for the system, coordinating all other parts of the system. The visuospatial sketchpad acts as storage for visual information, including remembering visual information that has been consolidated in long-term memory. The episodic buffer integrates information from the visuospatial sketchpad in the phonological loop. The phonological loop is used to store and manipulate auditory information. It has two parts. The first is the phonological store, which is like our inner ear, and can hold acoustic or speech-based information for 1 to 2 seconds. It allows you to repeat words after someone or to remember a series of notes on a piano. The second part is the articulatory loop, which is like our inner voice, and can revive old auditory memories. This allows you to remember your mom's voice or to think about the tune of a song without presently hearing it. How much can you hold in your working memory? Miller believed that the capacity was 7 units of information, plus or minus 2. A unit of information can be incredibly complex or very basic, as long as it is meaningful. He also believed you would be able to group multiple units together to form chunks. The more chunks you could make, the more you would be able to remember. This theory has been rigorously tested. Many researchers now believe that the real number may be closer to 4 units, but other research shows that this approach isn't nearly nuanced enough. This newer research demonstrates that the phonological loop plays a role in working memory capacity. For words, the capacity is determined by how many words can be pronounced in about 2 seconds. For example, one study showed that quickly pronounced words like wicket and decor were remembered better than words that took longer to pronounce, like morphine and voodoo. Are you ready? Okay, go. But don't take my word for it. Here's a demonstration. I asked a few of my friends to memorize word lists. The first list had all one-syllable words. What do you remember?
Pear, lime, peach, fig, plum.
Pear, peach, plum, lime, fig.
Pear, lime, peach, fig, plum.
The second list had all 3-syllable words. What do you remember?
Strawberry, tangerine, dragon fruit, apricot.
Strawberry, tangerine, apricot, nectarine, dragon fruit.
What do you remember?
Strawberry, dragon fruit, tangerine, nectarine.
Obviously, these people were able to remember more of the short words on the list. Was that harder or easier?
Significantly harder.
Which one was harder?
The second one.
Why?
The words were longer.
This has implications beyond just memorizing lists of fruit, though. Studies show that Chinese speakers are able to do math faster than English speakers, partially because numbers in Chinese take a little bit less time to pronounce. This allows Chinese speakers to process the numbers faster. Another side effect of this is that Chinese speakers are able to remember more digits than English speakers. Remember the magical number 7, plus or minus 2? English speakers can remember 7 digits at a time, more or less, but Chinese speakers average 9 digits. In conclusion, the limits of working memory capacity are complex and nuanced, but they can have a huge impact on cognitive processes. Thanks for watching!